are you?
Good, how are you?
Any question?
I have a question about the tree project.
Tree project, okay.
Yeah.
Tree project. Tree project, you really need to watch the video, okay? The video we have that you should get the idea of how to do it. So which actually that started from week 5, right? Week 5 here, the assignment. So basically the tree project description is over here, right? So you need to basically, this one is, let me see. This one is a, we should call it a try. Try is a special type of the tree, okay? So this one really is a try. We call it try, it's not tree, try.
Yeah.
So what try is actually when you build a dictionary, right? You build a dictionary, you don't want to waste the space. So you may have, say you have a dictionary, your dictionary may have A, B, C, A, B, C, D, okay? Your dictionary may have this. So just like this one, okay? Just like this one, you may have some of these different terms, right? So have T, TE, TED, these may be all legal words. So this try will keep the data in a tree, okay? So what the data structure is here say you have the root node. Root node means that there's no later, right? Root node is no later. So there should be a leading number. So here you should have a leading number. Okay, so you have a try. You have a try, and then you have a 0. So for each try label, you have a number 0. 0 means that none of these. Okay, so root actually initially is like this. Root initially is like this. Okay, that means that occurrence 0 time, no subtract. Okay, so initially your dictionary is like this. Okay, your dictionary is like you have.
It's like a list of the number and
you have a root node. Root node actually there's no word. Okay, now let me add a. If I add a over there, that means that there's an A later being added in. So in the subtry, they will have an A node. But A node at this time, it will have one number, one word called A, okay? And then subtry, there is also still none of the subtry. Is okay? Something like that. Okay, so that actually when you add a node A, when you add another AB, say AB, there will be a B over here. Okay, there could be an AA, there could be a B. So when you add a AB, then the data structure will change to this. Okay, you change it to the root node later. A, you have one node, and then after that you will be subtract, right? Subtract, we should have a here actually is initially should be AA actually is 0, okay, no subtract, and then AB should be 1, and then no subtract, something like that. That's after adding the AB. So it's recursively building the so-called tree. Okay, so here you given a try node, you need to implement these things, including how to build a try, how to measure the number of the try, and then also adding subtry and getting subtry, something like that. Okay.
And the size of the try is the number of nodes, or
the size is the number of the word you have.
Words?
Yeah.
Okay.
Number of the word you have. Okay. So they may be none actually is no later there. Okay. So something like that. Here is a description of this already. Okay. So here, and the thing you want to try actually is try this one called, there's an article called Declaration of Independence. Use that to fit in all of the data there. Okay. Put the whole dictionary into the try, and you should know about each word happen how many times. This one is one of the implementation that you can use it as the dictionary. When you build dictionary, it's one way to build dictionary. Is that okay?
Yes.
So the thing is that you must understand what this try structure is, and then try to build it. Okay.
Mm-hmm.
This one is that. Okay, try your best. Okay, if you can handle this one, then your knowledge about tree and recursion should be very good. Okay, and what I say that you may need to look at the video is there is a video, the video on the one. Let me bring up my slices. Okay, let me bring up my slices. For a moment, okay, sorry.
Mm-hmm.
So in this one called week 8, okay, week 8 recursion. Week 8 recursion and tree. Here at the last portion, we do have a tree, the whole video for tree. Okay, the whole video for tree right here, parentheses. Oh, that is, let me see. Before the step, okay, let me see. Here we have the whole discussion for tree, right? Type of tree, we talk about different tree. Okay, and before this type of tree, there's a simple tree discussion. So this tree discussion already teach you how to use list to represent a tree. Okay. So this one we already talked about it and how you can recursively doing that. But this tree and the try are different. But basically the basic idea is similar. Is that okay? So
yes,
work on this one first before you go to there. And this one already give you the idea of tree, how can use the list to build a tree. Okay. And later portion also has a video on the how to use a tree for evaluation, such as that you had a parenthesis and also the tree evaluation for prefix postfix evaluation of the tree. Okay, we actually have that. Okay, we actually have that. So basically, this one is a exercise. It's an exercise of how to build a tree and then define some function to it. Okay, so basically this try, the idea of the try is just very simple. You basically have a dictionary. So that's as soon as you have A, B, and B, C, and A, C, D. Okay, that's as soon as this dictionary only had this four word. So initially you have an empty node, right? Then you see an A, you should build an A node under it, right? So here you have one symbol over here. And then you have AB, you should have an AB over here. You have one symbol over here, right? And then you have BC should start a B part with one node over here. If you have ACD, then AC, you need to have a C node. C node actually 0 because no later none should be none or 0. And then you have ACD. This one should have one later here. So after that, you should traverse through the whole tree. So here you have 1, 1, 1, 1. So totally you have four words. Okay.
okay,
Okay. So when we build a try, something like this. Okay. When you build a try, when initially we have only A. Let's assume that we have only A. Okay. At that moment. Conceptually, okay, let me talk about it conceptually. Initially, conceptually, this try actually only had the root node, and then counter put there, and this sublist should be empty because no sublist, right? After that, you add an A into there, so here you add the little, and then your sublist will have only A portion. So A portion here, B we don't have any word, so A portion should be one word and subtract for A actually empty. So it's going to be something like this. Okay. And then after adding B into there, after A 18, that's a certain here we add a later called B9, AB. Okay. Just adding a B. So if you add the B over there, here, this sub-tree should have an A, and then it will also have a B over there. So you become this.
Okay.
So the length of the sub-tree actually depends on how many data you already have. So that's assume that actually you have A, B, and then you come with the D, but no C. So here you should have this one, and then C should be none. And then D actually adding in D's representation. So if you have, say, G, then there may be a lot of empty and then one G over there. But if you only have A, you don't need to actually store so many things. If you only have A, you just need that one, that is actually good enough for subtract. You okay?
Yes.
So from the subtract of the length of the subtract, you know that each node's next word is which one. So by the label, you know that how long the word is. By the label, you actually know how long the word is. By the depth, you know how long the word is. Because this label is actually A, B, C, okay? This label would be 2 letters. It would be A, B, okay? B, A, B, B, you know what I'm saying? So 2 letter label and then 3 letter, 3 more label. So the depth of this try is the longest word. Is that okay?
Yes.
Make sense?
Yes.
Okay. Is that okay so far?
Mm-hmm.
Okay. Any other question?
Only the 3D points in 2 weeks, the assignment.
Under one. Which one?
The 3D points in week 8.
Week
8, I think.
Yes. Assignment.
Yes. Yeah, the sample input, that has to be only one combination, right, of the letters. It's not mixed, right?
This one is like this, okay? You have the 3D data originally like this, right?
Mm-hmm.
So you need to sort by the order of X, Y, Z. So X is major. X major, and then Y, and then D. But when you do sorting, you sort Z first, then sort Y, then sort X. You will get this. You should sort from the last one first. Okay, let's look at this one. Let's look at this one. Okay, let's look at this one. So let's use a 2-dimension as an example. Okay, so let's assume that we have actually 1, 1. Okay, 4, 4, 2. And then 3, 10, and then -1, 2. Okay, let's assume that we had such a order. So if we would like to solve X, Y, say, okay, two dimension. So actually X is major, Y is secondary, right? X is major, Y is secondary. So we sort by Y first. So by Y, we should have 1, 2, 10, 2. Okay. 1, 2, 10, 2, and then so we should get 1, 1, okay, and then 4, 2, and then -1 and 2, and then 3 and 10, right? So that Y is sorted. Then we sort by X. Sort by X, then it will be -1, 2, actually 1, 1, 4, 2, and then 3, 10. Is that okay?
Yes.
So this is sorted by X, Y, this is sorted only by Y. So in case that let's assume that we have another one that is actually -1 and 1. Okay, let's assume that we have -1 and 1. The -1 and 1 after this is sorting. Okay, -1 and 1 actually it will happen on here. There's a -1 and 1. Okay, we sorted by Y, so you'll be here, right? So if be here, you'll be before this guy. So when we sort it by X, -1 is there, but 1 actually will be before this. So we will have the x as major, y as a secondary. Is that okay?
Yes.
So
Why do we have to start it backwards then?
So when we do the 3D, okay, 3D actually is there's a sorting a string, say XYZ. So you see a Z, that means that you at least have some three-dimensional tuple. Then you sort it by the third element.
By the third one, yeah.
Yeah. Sorted by the third element, you just do sort, right? You put the list there, say A list, and then key equals some lambda expression. Is that okay?
Mm-hmm.
That's it. It's a lambda expression. You need to figure out how to put it there. Is that okay?
Yes.
That's it. And then second one, you sort y, same thing, you sort, and then key change it to different lambda expression. So x change to different lambda expression based on the sorting string assignment. Okay?
Okay, thank you.
So this one should be okay. Call it, this one, we don't need you to write a sorting algorithm. Using the default sorting should be okay. We are not testing you on the sorting anymore. We are testing you on sorting out the data. So use a standard function is okay. Second one is an inner call. You must know about adding function. So let's say add one, you print z equals 0. So z is a variable that will be affected by the add function. So add one, you have z. So this add one, apparently it will generate a function. It will generate a function so that that function will be applying to add2. Okay. And the sum of this guy will apply to this one. Okay. It will always return a function, return a function, return a function. Okay. As for how the return of functions, you should, so this add should return a function every time. Okay. Should return a function every time. So it should be a function that returns certain function. So what I can tell you right now as a hint is this one you must do define add. Okay, this add no problem. There is some number x there. And inside there may be a function that been generated, G function. Okay, how you do it, that's you need to actually know. Okay, but at the very end, you should return this G function, so that that function can be used to apply to the next function. So about this function generating function, same thing in the chapter A. You should also watch the video. We do have cover of the function there. So watching the class lecture is very important. Is that okay? This one is in JavaScript. What I can say is that here we already give you the hint.
Yeah, I know.
Okay. Okay, that's the best that I can tell you. Okay. But we do have cover it. We do cover it. And we do show some example. If you look at the video, we do show the video. The idea is that I want you to really learn what is high-level function, what is querying, what is high-level chaining, okay? And the idea of getting vector for vector output, function input, generate vector, and also getting vector return function and getting function, return function. So these are the functional programming. Your function can generate data or function, getting data or function, generating data or function. Okay, that's what we learn. If we don't learn this one, we really don't know what functional programming is. Is that okay?
Yes.
So he already tells you what's a querying. Okay. And more advanced would be a decorator. So that's some feature for it. Let's see, there's some question here, okay. Indian algebra here. Dimension of the polynomial, you just find the length of the list will be enough. So that's not hard, okay. That one is not that hard. Let me talk about the polynomial problem, okay. That one, you actually have a coefficient. So the coefficient is actually like this. Okay, so it actually is A0, A1, A2, whatever up to AN. Okay, so totally this will be n plus 1 number, right? N plus 1 number, and this one is represented your AN xn plus AN minus 1 xn minus 1 plus blah 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 plus A1 x1 plus A naught. Okay, so that's the polynomial you represent. So the dimension of the polynomial is you should be able to find out from this number, right? You should be able to find from size. You should know about the dimension of the polynomial. Polynomial is this guy, right? So that should be an easy problem. Okay. Is that okay? Jonathan, is that okay? Yeah, yeah, but there is no exponent. There is exponent, but we only take the coefficient. So there is no exponent. You just use the length of the list, should know it. The length of the list tell you the story. Not exactly, but tell you the story. Is that okay?
Yeah, can you hear me?
Yes.
Okay, thanks.
Yeah. Is that okay?
I think so. I was looking up and it seemed pretty complicated, so I wanted to check.
No, it's not complicated. It's just like this. It's just like this. So
So
if you implement the f function, say that's assume that you are adding the function, right? So this guy is like this. Let's actually use an example. Okay. So let's assume that we have an equation that actually is x squared minus 1. So the coefficient should be minus 1, 0, and 1, right? Degree, this length is 2, as is 3. So degree is this, right? Dimension is this, right?
okay.
Yeah. Degree is this. And if
The
we
degree
have
the degree is the total number of coefficients, and then the dimension is just one less than the degree.
no, degree is the total number of the highest order actually.
Okay.
So the polynomial we only have, say, second order equation, right? It's a quadratic equation. So this one is actually order of 2. Or dimension you call it 2. Is that okay?
So the dimension would be the largest exponent, right? The 2?
It's actually this one.
I mean, the degree. The degree is the...
Yeah.
Right. I think I did mine assignment incorrect. Okay. I guess I got a little confused.
If you resubmit through email, I will correct your square, right? Is that okay?
Okay.
I think that. So if you feel that okay, I made a mistake and I submit, I cannot change my data. It's okay. You just submit to my email. If I saw it, I will update it. If you see that I did not update your grade, let me know. I always would do that. Okay, because some people submit early, some people submit late. In case that you do think that you just mess up somewhere. Okay. So if you want to implement this, say there are some equations like in the polynomial, you have the f function that you can implement, right? So you have your own equation, say x squared minus 1, and you add x cubed plus x plus 1. Okay, so these two actually is what? You have minus 1, 0, and 1. The other guy actually is what? It's actually 1, 1, 0, and 1, right? So you basically are summing this one up. So 0, 1, 1, 1 here. Is that okay?
I guess I'm getting confused. Where are you getting the -1 at when you're
negative 1 is the A
minus 1.
A naught. This is A naught.
Oh, okay. I thought you were. I wasn't looking at that. I thought you were looking at the x3 plus x plus 1. So that's what.
No, this one we present this one. This one we present this one.
Okay. Gotcha.
So basically, it's very simple. Okay, don't make it too complicated. Your equation say an xn plus an minus 1 xn minus 1 plus blah 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 plus A1 S1 plus A naught. Okay, so usually like this, right? So I don't want you to do reverse. So we put the lower coefficient first. Okay, so if you have S squared plus 2S plus 1, this one should be 1, and then 2, and then 1, right? If you have 2S squared plus S minus 3, you should get minus 3 and actually 1 and 2. Okay. So addition, you just do this, do addition. Subtraction, you just do subtraction. You know what I'm saying? Should be fine.
Yes, okay.
Okay. And how about evaluation? So evaluation means that you have f of x equals x squared plus x plus 1, right? So this one is evaluation. What you should do is actually, you should do this. You have, let me use a different coefficient. This is really bad coefficient. So we have 2x plus 3, 2x squared plus 3x plus 1, okay? In this case, what evaluation you should do is that, okay? So let's assume that here I actually pass in a 2, f of 2 to evaluate, okay? So if you want to do this evaluation, usually you do call function is evaluation, call some value x, okay? That you should return some value. So that one is evaluation. That means that you have polynomial, right? You have polynomial. So you create a polynomial. That's assume that here you have a p polynomial. You create it by polynomial, okay, of this the so-called 1, 3, 2. Okay, you create this, and then you want to evaluate polynomial 2, and you get a value, say y. Is that okay? This is called evaluation, and in the implementation, you just put the evaluation on call and self and s, right? That is evaluation. So that function, how to write this function? Okay, so that guy you want to do evaluation. So here the equation I write it here. Okay, it actually the f of x equals 2x squared plus 3x plus 1. Okay, so you put in 2 there. So you actually go from backward. It's 1, 3, 2. So you actually starting from the last element. The last element added to a something called sum, right? The first one, you get that one. Second one, you actually do 2 times the sum times 2, okay? And then plus 3, that you get another sum. And next one, you have sum times 2 plus 3 times 2, and then plus 1. You get another sum. So this one, you will get sum equals what? The first sum is 2. So, okay, the first sum is 2. So you get 2 times 2 squared plus 3 times 2 plus 1. Eventually, you get this. So going backward, traversal. Is that okay?
Okay.
Yeah, I think I got the add and subtract and call and
Yeah, try as many as possible. Even multiply is okay, right? Even 2 polynomial, you try to multiply. You do multiply. So multiply is that you have a polynomial 1 actually times polynomial 2, right? I'm sorry, polynomial 1, okay. And then should be P1 times P2. When you do this, okay, the multiply, it would be something like this. You should have 1, 0, 1, okay, for example, s squared plus 1 times s cubed plus 1. That's also this. It's this 1, 0, 0, 1. It just do long multiplication, okay? So this one conceptually is like 1, 0, 1, you have 1, 0, 0, 1, something like this. You do long multiplication, so you get 1, 0, 1, 0, 0, and then 1, 0, 1. Is that okay? This 0, 0 is caused by this. Is that okay? And the sum would be 1, 0, 1, 1, 0, 1. Right? Is that okay? What? Is that okay? One more time. Okay, one more time. It's actually no space. I should allow more space to do it. Okay. So this one, actually, one more time, you should have 1, 0, 1, 1, 0, 0, 1. So you multiply these two equations, it will be 1, 0, 1, 0, 0, 0, because 0 times 12 times 0 times 0, 0, 0, and then last one is 1, 0, 1. So the sum is 1, 0, 1, 1, 0, 1, and that is this one.
Oh, okay, okay.
That is long multiplication. Okay, even division is possible. Okay. This is remainder equation. This is quotient equation. That's too much. That's too much. Okay, but it's also possible. Okay, I don't need try as many functions as possible. Not for me, for yourself to study. Okay.
Professor, when you're using the I guess the call or the you have the dunder call and then another dunder. How do you control what happens if nothing is passed in to where your x value would be 0? Would you just define it as 0? And if they pass something in, you would change the x value?
If I change, no, you evaluate, you don't change the x value. You evaluate, you don't change the value. The polynomial don't have value.
Okay, so like in your example where you I don't know if you can see your example, but like you have print P1 and then parentheses 3, so you're passing 3 and it's being received by the call function, kind of the dunder call dunder, and then that plugs it in. So where do you like dictate what happens if they don't pass anything? So the line before you just did
Okay.
P1.
Let me go back to week 6. Okay.
Okay.
I'm trying to understand your question actually. Okay. So not passing. What do you mean by not passing? This print function.
I can't see what you're seeing, so I'm not sure.
You cannot see what I'm saying.
I just see a blank white screen.
Oh, okay. Let me see. Sorry. Yeah, I should share. Yeah. Can you see now?
Okay.
You're talking about this one.
No, above that, where 2 lines above that, or
This one?
3 lines. Yes, that. So that 3 is going to the call method.
You need to call. Call will get a value.
Okay. So I understand that, but before that one where you just have print P1 and you didn't pass it anything, how does it know that it's going to be 0?
P1 created with only a 0.
Okay. All right.
You know what I'm saying?
Yeah, okay.
Yeah. Is that okay? And here you have this. Okay. You have this. We pass 3 call. How do you pass multiple coefficient to a function?
Using varg args.
Yeah, we using the argument list. You know what I'm saying? Use the star argument vector.
Right.
Yeah, using that, you will group the whole thing into a list. Okay.
Now that you have the assignment document up, the one specifically the dimension one that I was asking about,
Yes.
the print p2.dim says the dimension is 2 there,
2, yeah.
but the size of the list should be 3, right? It should be 1, 2, 3.
We are talking about the highest order. The dimension we are talking about the highest order. So it's
Okay.
N we're talking about, yes.
Oh, okay, so it's the n of the
The highest order of the coefficient. Yeah.
okay. All right, thank you. I
Yes.
just needed clarification on that one.
No problem. Okay.
Professor, when you're passing 1, 2, and 3 to polynomial, you're saying something about a star argument?
Star argument, yes.
Oh, would that not work if I just pass it an array? It's like just pass an array and then split it up inside the class.
Yeah, you can write constructor of different flavor, yes.
Okay, can you talk about, because I guess you were explaining, but I didn't really understand enough about it to get what you were saying about the
Let me try some function. Okay, no problem. Yeah, one moment.
Yeah.
Okay. So if you are not familiar with actually this one is when you look at it, we cover it in some of the chapter, I don't remember which chapter, okay? We do cover it in the video, okay? But it's okay, let me actually redo it one more time about the grouping of the variables. Okay, no problem, okay, one moment. I try to find it directly. I usually store our conversation, the program, okay? So here is this one, now is week 6, right? This week 6. That's demonstrated by a maximum function, okay?
Also, Professor, does
Yes.
some of these assignments, can we submit them in a different language versus using Python like Java?
I tend not to do it. Is okay. Java's functional programming is not as easy to do. So you don't get the full support. So
Well, I was just speaking about this object-oriented programming for this assignment.
this assignment alone, if you
Yes.
really cannot do Python, I'll be okay. If you really cannot do Python, but I would suggest you just try to go through it. You know what I'm saying? Try your best to conquer it.
Okay,
The time
it's not
is-
hard. It's just, it's so simple. It makes it difficult because it's so simple, if it makes sense.
You can always ask question, okay? Don't worry. So here, let's assume that we actually try to have a list to find the maximum, right? Okay. So here, if you want to use a list, it would be say like we have an M. Okay. So here, if actually here a list, okay, the length of the a list is actually equal 0. Okay, this one will return 0. Okay, no maximum. That's assume that we only consider positive number. So M will be equal A list. Okay, it's first element. Okay, and then for okay X in A list. Okay, if actually X greater than M. Okay, M will be X. Okay, eventually you will return M. Right, this is a maximum traditional way of finding the maximum. So let's try to find maximum of the array 5, 4, 2, 10, 1. Okay, let's assume that. So this one is the traditional way we do it safe. Okay, and we run it. Okay, we got 10, right? That's maximum. So if we want to write another function, let's actually define max2. Okay, so max2 we actually get star argument vector. Okay, that is. Now we group all the data together. So here you should think about this. You will have a list. Okay, something like that. You will have that. So if actually the length of the ARGB, okay, equals 0. So actually let's copy the whole thing here. Okay, it's just grouping the whole thing into a list. The idea is that, okay. So it's just grouping the whole thing into a list. Does that make sense? just grouping this whole thing into a list.
Okay, so it just makes a list for you essentially.
Yeah. Just don't
Okay,
worry.
okay.
It's actually just as simple as this. When you
Okay.
get 2 stars, so you get 2 stars, so define maximum. Okay, this one is not maximum. So actually, let's do make dictionary. Star AR KARG. Okay, this one. Okay, so this one will create a dictionary. So that's actually just print the KARG. Okay, let's just look at it. Let's don't do anything. So here this one will be actually let's do make dictionary of A equals 1, B equals 2, C equals 3. So that one is grouping, but grouping and creating a dictionary with key and value, key and value, key and value.
Okay.
Got it?
Yeah, I got
So
it. Thank you.
The use of KR double star K argument, okay, and the list of argument vector ARGB vector. Okay. So why we want you to actually learn this and insist on using Python, because Python give you the most language feature that you can have using one language. You know what I'm saying?
Yeah.
Very, very flexible, and you do get confused sometimes, but please try your best to continue using Python, okay? Because that is some of the language, the most versatile language you can find. So you get all kind of language aspect that you need to learn, okay? You know what I'm saying? So it's more quick. It can support most things you can do right now. What is the prototyping language? Okay. Okay. Any question? Okay. That STR things I explained it last week. Okay, so you can look at the video last week. We do discuss that last week. Okay. Any more question? Okay, so you see that the problem get harder, but you try your best. Okay. These are actually trying to teach you all kind of the different things in Python and the programming language. Okay, so let's actually look at the schedule one more time. Okay.
So Dr. Chow, I apologize. I thought I understood what I was doing. Now I'm more confused now
Or what?
with the assignment that we're doing.
Which one?
The one we turned in today.
Today is this one? Polynomial?
Yes. Right. I mean, I guess I don't know. It just seemed like it was very simple, but now it seems way more complex than what I don't know. I'm just a little bit more confused still.
Which
Maybe
way,
I'll wait after the class to ask
yeah, which one you are confused?
Okay. So I don't know, because okay, so first of all, like in like the constructors per se, I did 2 different type of constructors. I did a default constructor.
Uh-huh.
And then I did the one with the arbitrary numbers, and I guess I don't know. I'm confused. Maybe I'm overthinking it and I'm confusing myself. I don't really know.
You don't need to confuse yourself. You just do this one. That would be enough. Do one way, it will be enough. You know what I'm saying?
Right. So then how do I get down? Because I thought the first thing you told us to do is just put in to make a constructor that takes just a random amount of numbers. Like it doesn't have a specific amount of numbers. And I guess, like he said, you could make an array, but I didn't think of array. I just thought about to use the what is it called? Args, vargs, or varg args, star args, yeah. I just did that because that made sense to me. And then I did a loop.
So you do a loop, you don't need to a loop. Okay,
Okay.
let me just get this straight.
Okay.
Let's assume that I create some sort of semi-polynomial, okay? Just make it so simple. Okay, the printing may not be the same, okay? The printing may not be the same, but this one just a P1 equals a polynomial of 1, 2, 3, okay? And then print P1, say super easy class, right? Wait, non-string type. Okay, I'm sorry. So this one I need to make it as a string. Okay, sorry for that. I'm trying to make it very simple. So basically, the argument list is actually by itself is a list. Wait, let me see. Non-return type. Non-return type. Okay, this one actually is a list, but they don't know it's a list. Okay, let's do this. Okay, don't do this. Let's do actually. St. I need to return a string. Sorry for that. So string that's actually equals empty. Okay. Let's do this. Let's actually have the left bracket. Okay. And then for okay, I in range of the length of the self.list. Okay. If I equals 0, okay, we actually do s plus equals okay, the string of the self that I'm sorry, we actually do self.list i's value, we convert that to a string and add it to it. Okay. Else we s plus equals comma plus okay this thing. Okay, you need to return a string, so I make a string at the end. Actually here, so s or plus equals the right side bracket, and then return s. Okay, sorry for that. It requires string, so I print is not okay. Print is not okay. So here I should actually do okay. Print P1 is okay. Let's go. Is that okay? So this one is okay. First thing I want to say is this one it is a list, so you can directly convert it to a list. Then that is the list that you don't want to have. Okay, no matter what argument they are, they will be put into a list.
Right, but
Okay.
do we have to do all of that? Couldn't I just have did pass in the args var v and the parameter and just loop it right inside of that first function without before you even
Up to you.
and print it out in that function at the same time
Print
without building the which I guess we do. Okay, forget what I'm saying. That's fine. That's fine. Because I did it differently, but that's okay.
This one printing is like you have some data, right? That's actually go through this one. This one you will use it later many times. So you have A, B, C, 3 numbers. So we do print this one. And if it's the first one, we print A. Second one, we print comma B, comma C. And then at the end, you add this one. If you look at my program, this portion is this. Then you do this, and this. Okay. So let's assume that we are doing polynomial. Polynomial, you have 1 plus you have 1, 0, 1. So actually you should get 1 plus s. No, I'm sorry, plus s squared, right? You should get this one, right? So you should print 1 plus s cap 2, right? Okay, so there's a number. You keep going. There's a number. Your index is your order, right? you index your order. So let's get one by one. Okay, so the first one, if the index equals 0, you just print x without x, right? And then that's the first one. When I equals 0, you do this. I not equal 0, you do plus, and then your coefficient, say 2. Then print x, and then cap, and then your index. This one will be 2x squared plus 1. Is that
Okay. Yes.
If the coefficient equals 0, you don't print. You kind of bypass it. If the coefficient not equal 0, you actually print this in a plus sign with the coefficient, and this guy with the index.
Okay, gotcha.
Is that okay?
Yes.
So it's starting from A0, okay? Is that okay?
Yes, thank you.
A0, you must print 0, okay? Other number you can omit, but A0, you must print 0. Why? Because there might be a chance that you have only 1 0. No order. You want to say A0, you cannot say A0 equals 0, so no print. No. A0, you still always need to print a 0. Is that okay? Otherwise,
Got it. Okay, I see what you're saying. So I see what I was doing
in
wrong.
case that you only have a 0, you have to still need to print a 0. Okay. Other thing, you have 1 0 0 0. This 0 you don't print. Don't print. Okay. So this one you print this one 1, and then no print, and then up to here you do plus, and then 1 the coefficient, and then x, and then cap, and then this one index is 0 1 2 3. So here 3. Is okay? You should get this. Okay, you should be able to get this. Any more question? Let me see another question. Okay. Any more question? Try your best. Okay, try your best. Try to understand it. So we have a lot of material, I should say, because the whole semester we trying to go over different aspects of the Python language. Okay. Try different language. I don't suggest it because here we try to go into the different aspect of Python language. So we cover everything in Python. Okay. If you just do something in, you just go over to do Java or JavaScript somewhere. I mean, later you still need to go back to Python, right? So you are actually may duplicate your effort. And there are something you need to learn, but you actually just skip it. Okay. So we use Python, I say that as a pilot language to learn programming language features. Okay. So can we use a Java for it? Yes, of course, I can develop a whole course in Java or JavaScript. Okay. Any other language, any language, I can use it as a pilot language to develop this course. But I don't want this course to become a programming language that teach 20 language, but no depth. You can teach the programming language, teach you 20 programming language, but at the end, you touch very little on each of the language. Okay, we try not to do that. We try to do very deep in one language, Python. You don't need to worry about other language, but this one you dig extremely deep, including your memory model, your imperative programming, object-oriented programming, functional programming, recursion, language translation. Okay, everything one language to do it. You know what I'm saying? Everything one language. So by doing this, you actually will have a chance to learn more of the feature in that language. Okay. Any question? Is that okay? So Python language is very important because you need that language to learn a lot of feature. Yes, Java is better in OOP. Yes. Okay. So object-oriented programming, no language can beat Java as a teaching language. Okay. That's why in high school they use Java as the teaching language for the AP computer science. Okay. That actually AP course is using that. But in terms of overall versatile, okay, I think versatility, I think that Python is better, okay, especially in functional programming. So in object-oriented programming, you try Java, but later you go to function. Wait, you got in big trouble because the object feature of the Python, you kind of miss it. You kind of miss it. You know what I'm saying? You will miss those kind of features. So when we talk about function, you do have a trouble of understanding the class now. So we need to mix the functional programming with classes, then you are in trouble, okay? So I strongly suggest that just try to insist to use Python all the way. Sorry. Any question? So in terms of difficulty of the different chapter, I would say chapter A is the toughest one of all. The whole course, the lecture A, the recursion, this one is the one hardest one, okay, I should say. So expecting that, okay. Expecting that the number A is the longer one and toughest one because it teaches you the recursive programming. So if you don't do well in lecture A, okay, lecture 9, it comes the scheme language. We switch to different language to do functional programming. At that time, you'll feel very difficult, okay, because you haven't finished the recursion. So lecture A definitely is the hardest one here. So from 7 and 8, the functional programming, it is a totally new programming paradigm. So you need to pay more attention to it. It's totally different from the way you do Java or something else, okay? Is that okay? And does C language has functional programming? Yes, they have the functional programming. Does Python, Java has functional programming? Yes, but very little, okay? Their support for functional programming is very little. So Python support better in terms of imperative programming, object programming, and object-oriented programming and functional programming, okay? And also higher order recursion. This one, Python is the best. Python is so far the best AI language. And why I want you to learn so much Python is Python is #1 AI language, okay? You want to learn AI. This is the chance that you build up a solid foundation for learning AI. You know what I'm saying? Is that okay?
Yes.
That's why I don't want you to try otherwise. Okay, try otherwise. It's okay. I will accept it. I'll grade it. But you lose the opportunity to learn the core of AI. Okay. Here you build a foundation, and later when other courses talk about AI using natural language package, right? Talking about robotics using Python to model it, you kind of will need your background in Python to support it. Okay.
Okay.
Yeah. Try to stick to it. Okay. Stick to Python. Any more questions? Okay. Any question can ask. Okay. So yeah, this next week is week 7, right? So some students work on week 8 are actually early, but week 7, please pay more attention. Okay, that's what all I can say. This functional program is totally different. The key difference is it is not traditional imperative programming. Okay, and if you actually combine with chapter A, lecture A, these two are one unit. Okay, these two are one unit. Actually, is lecture 7 and 8 is actually one chapter, functional programming. Okay, so week 7 we pretty much on the basic idea of what is functional programming. Okay, we're basically talking about what is functional programming. Week A is the use of functional programming. So week 8 is a little bit even harder than week 7. Week 7 only talking about what is functional programming. Week 8 is you need to use that, applying it to the real problems. So week 8 is kind of even harder. So you can wonder why here is a functional programming, but we talk about functional programming, okay? We talk about structure, functional programming structure. We talk about higher order function. We talk about currying. We talk about decorator. We talk about chain rule. We talk about recursive function. So these are different aspects of the functional programming, okay? So we finish functional programming here for different type of functional programming. Then, okay, also mutual recursion. And then after that, we go into tree. So we go into tree because tree is in this way, okay? And recursive function call is going this way, whatever way, okay? That's a recursive call. So recursive call is the best, tree is the best application for recursive call to apply on. So that's the best test. This is a best test environment for your knowledge for functional programming. So you learn functional programming, apply it to tree. You know what I'm saying? And why tree is so important over here? It is, okay, the goal of this course is to learn language translation, okay, language translation. The goal is to learn language translation. So the first step, you have x plus y times 2, okay? That's the sunda, and actually that's the sunda, x is 3, y equals 4, okay? So you have this, and the first step, we do tokenization. So we got this, okay? We got this tokenized, okay? In lecture 10, we'll talk about, tokenization. So you got this tokenized. Then after you tokenize it, next one, you do this. You do times 2, okay, plus, and then x and y. So you build that into a tree. So this one is so-called a parsing. Okay, parsing. This one is lecture 12 and 13. Okay. So your language come in, you convert it to tokens, then you convert it to tree, then you apply your recursive function onto it to do evaluation. That's why I want you to use the class, use the call function to do evaluation of some polynomial, because later you are going to evaluate a function, evaluate the tree using functional programming, and go through each node of them to evaluate it, right? And then you can translate this whole program into a result. You execute it, and you got something like 14. That would be the answer you want to have, because you apply the recursion to it and you do evaluation to it. So we do translate from input, that is a expression, to the output, that's the desired result you want to have. And this is a simple example of interpreter, right? Your Python, you have Python, you put in x plus y times 2, and you got a result here, 14. That's a simple operation of interpretation, right? Is that okay? Hello, hear me? Wait.
Yes, we're here.
Yeah. That's what you are learning here, okay? That's what you are learning. So if you look at every chapter we have, they are organized in a way to best support you for everything, okay? Best support for everything you need for the programming language, okay? So we start with the memory model, and then imperative programming, and object-oriented programming, then functional programming, then recursion, then knowing about a scheme language, then knowing about what's tokenization, and then knowing about parser, and then putting parser and tokenizer together to become a calculator. And then after that, trying to understand what is repeat loop, and then design a scheme interpreter at the very end. You know what I'm saying? That's the whole process. The scene is one course. We put them together, okay? And this one, as I said before, this course is the flagship course in Berkeley. This one is the flagship course in Berkeley, okay? So basically it is a very important course to AI. And it was also taught by MIT, okay? MIT was originally in MIT actually. MIT originally is a book is written by MIT and they have a course. Okay, they have a course there, okay? This course was there since 1980 something, okay? So very, very famous and long-term course. Okay, any other question?
No.
No problem. Can we done today here? Yeah, any more question?
No, I'll do my best.
Yeah, have a good day, okay? I
You
need to
too.
do something else, okay? Thank you.
Okay, thank you.
Bye-bye.
Take care.